For chapter 6.1 is about the rational index. First, we need to know what is radical, or what is the root sign, what's the meaning. For example, you have this idea. If for square root, this is called, we call square root 9. We know that equal to 3 because 3 square is equal to 9, or negative 3 square equal to 9. Both we call the square roots with this sign, square root. That means the number here, for example, 3 square equal to the number here. Okay, more example. For square root 16 is equal to 4 because 4 square is 16. In more general, for any number here, this equation x to power n equal to a, then we can find the number x we call the nth root of a. More specific, if n is 3, then this x we call cube root. If n is 4, we call x as a fourth root. Okay, we go to some example. First, we introduce a new symbol, radical sign, like that. For square root, you'll have learned before. And also, if cube root, this number at the left corner, top left corner, the small number here. For nth root, fourth root, the small 4 at the left top corner. For nth root, like this, we all call the radical sign. For example, here, the cube root of negative 8 equal to negative 2 because negative 2 to the power 3 is equal to negative 8. So the cube root of negative 8 is equal to negative 2. Okay, fourth root means you need to find a number to power 4 equal to 81. 3 to power 4 equal to 81. So 3 is the fourth root of 81. And a negative fourth root of 81 equal to negative 3. And more example. For 16 square root equal to 4. But negative 16, we cannot find the square root we know before because no number square is a negative number. For example, positive 4 square is 16, but negative 4 square is still 16. So you cannot find the square root of negative 16. So, more example, 8 cube root equal to 2 because 2 to the power 3 is 8, or 27 cube root 3, or negative 8 cube root. This time we have answer because negative 2 equal to, because negative 2 to power 3 is negative 8. Also, for negative 27, it's negative 3. So, you need to know the nth root, this number here. If this number is even number, here no number here, it means 2, because square root is 2. Take square root. This number is an even number. For negative number, you cannot take the root. But this number is the odd number. Even is negative number here, you still can find the root. More example, for 16, yes, fourth root is 2, but negative 16 fourth root, no answer. 32 fifth root, 2, negative 32, fifth root negative 2. Only this number is odd number, you can take a negative number to find the root. Here is some laws of index, but they are the same of we learned before. Nothing special. Here's some simple example to use the law. Okay, for the first one, even the number is the fraction or a rational number, we still can use the same way to do. For times, we add them up, become 3 over 3 is equal to 1, so the answer is x. Okay, the part B is division. Then you need to minus the index, 2 minus 4 over 5, and then become 10 over 5 minus 4 over 5, then is equal to 6 over 5. For third one, to x 3 over 4 y to power 4, then this 4 times it times both become x to power 3 y to power 4. For D, similar, x to negative 2 y to power negative 2. For negative index, it is a reciprocal, reverse the fraction, y squared x squared. For a rational index, or the index is a fraction, we need to know what's meaning here. First, we show you an example for square root 2 times square root 2 must be equal to 2, because square root 2 times square root 2 is square root 4, and square root 4 is 2. So you have a result, square root 2 square is 2. We can use a similar concept if we find square root 3 times square root 3, it must equal to 3, or square root 8 times square root 8 is equal to 8. You can think about this concept, but the result is that square root 8 square is equal to 8. The number takes square root and then square, it will become the original number. And if a to power 1 over 2 square, we can use the index law. The index can times become a to power 1, so it's a. So from these two results, we know a to power 1 over 2 and square root a are the same number, because the square of them are equal to 8. So we have the result, a to power 1 over 2 is square root 8. And then look at this, the example here. For a to the a cube root of a, if the cube root of a to power 3, it will go back to a. Because cube root and then power 3, it will cancel out and become the original number. For a to power 1 over 3 to power 3, also to equal to a. So we have similar result. These two numbers are the same. We have a to power 1 over 3 equal to cube root. We use a similar concept or similar logic for the nth root. For the nth root to power n, same number. For the power 1 over n to power n equal to a, these two numbers are same. So we have this result. That means the index is 1 over n is same of the nth root. If the index is like that m over n, that means a to power 1 over n times m. That means the nth root n to power m. This result, the result is here. Now we try some example. The first one is the part number 1. We try to convert the fractional index or the rational index to a radical sign. For 1 over 3 means cube root. For negative number, negative means the reciprocal. That means 1 over. And 1 over 6 is 6th root. Okay, this one, the C part. Negative index is the reciprocal. 4 over 5, 5 is a 5th root. And a to power 4. Okay, number 2 is the converse. Do the reverse way. For a, no number at top left corner means a square root. That means 2 over 2, 5 over 2. B, the top left is 3, means the index is over 3, and to power 4, 4 over 3. Part C, it is negative index because it's a reciprocal. At 7 means over 7, and 3 over 7. Okay, for this 3 example, we need to find this number, but without using calculator. A calculator can find the exact answer, but now we try to do it without using calculator. Okay, for this number, we need to know they can convert to some number, a smaller number to the power. So we need to know some number we always see in this kind of question. First, 2. You can list out the power of 2. 2 to the power 1 is 2, and 2 squared is 4. 2 to the power 3 is 8, and 2 to the power 4 is 16. So you know 16 is 2 to the power 4. Also, 3, you can list out 3 squared is 9. 3 to the power 3, 27. Okay, for A here, 16 you see you can change to 2 to the power 4 and the power 3 over 4, and the power you can times it, become 2 to the power 3 times these two number. So 2 to the power 3 equal to 8. Okay, B. 49, 9 over 49, negative 3 over 2. Change 9 is equal to 3 square, and 49 is 7 square. And then you can times the index, become 2 times these 2 times it, become 3 to negative 3 and 7 to negative 3. And then for the negative index is we can change to reciprocal. 7 to the power 3, 3 to the power 3 equal to 343 over 27. You can find it by your calculator. So no calculator. 7 times 7 and 7 equal to 343. 3 to the power 3 is 27. Okay, and C, for the cube root, we can change it to 2 over 3 here. And then 27, become 3 to power 3 times the index, it become 3 square and equal to 9. For part A, it is a division, so the index you can minus, and then make the denominator same as 12. It is 16 minus 9, so the answer is a to power 7 over 12. B. You see a 2 square root here. You need to know the order. You need to do it one by one. First, do the inside one first. Must be inside one first. Times for square root is 1 over 2. And then for the there's a time, so the index need to add up 2 plus 1 over 2 equal to square root a to power 5 over 2. And last, the square root, the outside square root is the power 1 over 2, inside 5 over 2, a to power 5 over 2, and 2 index is times again, so the answer a to power 5 over 4. For C, for the numerator, the fourth root, so 5 over 4, and the denominator 4. 4 is 2 to power 2, and times the 3 over 2. For the inside, 1 over 6 times 3 over 2. Okay, and then the denominator become 2 to power 3, and a is after you simplify is 1 over 4. It is a division, so minus the index, and the denominator 2 to power 3 is equal to a, so answer is a over 8. For the next example, first we simplify the numerator and times the index. Negative 1 over 2 times 2 become negative 1, and then b, 2 over 3 times 2 is 4 over 3, and the denominator keep the a to power 1 over 2. For the cube root is 2 over 3. And then for division, you need to minus the index. And this one is 4 over 3 minus 2 over 3 equal to a to power negative 3 over 2 and b 2 over 3. And final, you need to express the answer with positive index. That means for the negative index, you need to change to a reciprocal. 3 over 2. Okay. For the final example, we need to solve the equation. You see the equation like that. We need to find x. Okay, now the first in the question is x to power 2 over 3. We need to find the answer in the form x equal to something. So in the last step, you will see x to power 1. The last step, or your answer must be x to power 1 equal to something. So you need to make the index become 1. So I times number both sides to the index, and then make the number in the index equal to 1. So I choose 3 over 2, because it can cancel both the numerator and denominator. At the right side, same thing. So left side become x to power 1. For the right side, 9 can change to 3 to power 2. So x is equal to 3 to power 3, so x is 27. Okay, one more. B, x to power negative 5 over 2 equal to 32. For both sides, we need to times the index, a number. I'll choose negative 2 over 5. Because the final answer must be x to power 1. So I need to cancel the 5 and 2. And also it's a positive 1 in the final, so must be times the negative index to the left, to both sides. Now become x to power 1. For right side, 32 is 2 to power 5. And you simplify, become x to power x equal to 2 to power negative 2 is equal to 1 over 2 squared. So the answer is x equal to 1 over 4.